So the first problem that we run into is in the case that we have what are called dangling nodes in the web graph. And a dangling node is simply a node that does not point to any other nodes. So in this case, node V is a dangling node since it has no outgoing edges anywhere. And an equivalent way to say that is that the out degree is 0 for a dangling node. And dangling nodes will actually lead us to have no solution in the PageRank equation. And to see that, you can note that V's importance score has to be equal to the sum of the importance score on all of its outgoing links. Just like we said before, W has W over 2, for instance, and also W over 2 on this link. So when we add those importance scores together, since W is spreading its importance score out, we're going to get W, because W over 2 plus W over 2 is W. Well, V doesn't have any outgoing links at all. So that means that it's spreading 0 importance score throughout the graph, which would mean that V has to have an importance score of 0. Then that will actually propagate itself through the rest of the web graph, and that'll cause Z to have to be equal to 0 as well. And that'll in turn cause all the rest of the importance scores to have to be 0 once one of these is 0. So we have no solution. And the way that PageRank actually deals with this is it assumes that the dangling nodes will point to all of the nodes in the graph. So there's a link to W, a link to X, a link to Y, and a link to Z. And actually even a link to V itself. So there's a self loop here, we assume. And so now V went from having an out degree of 0 to having an out degree of 5. And this makes sense intuitively because if we landed on V, if we were a random surfer and we had nowhere to go, then we'd be forced to enter some random URL into our browser, and then we'd end up at one of the other nodes in the graph. The other problem that we face is in the case that we have an unconnected graph. So there's two separate portions of the graph, and in this example right here, A, B, and C form one subgraph, and D and E form another subgraph. Now the strict definition is actually a connected component in this case. We're looking at two different connected components because A, B, and C are each connected to each other, and we can get from any node to any other node in this connection, but there's no connection to any of the nodes outside of that connected component. So there's no way to get, for instance, to D and E. And similarly, D and E are both connected to each other, but there's no way to get back to A, B, and C. And so actually what ends up happening when we have unconnected components, or we have more than one connected component in the graph, is that we get an infinite number of solutions to the PageRank equation. So that's also another problem, because then there's no way of determining which nodes are more important than others, because there's no unique set of importance scores, so we have no consistency. And the way that PageRank deals with this is actually to take into account what we neglected initially, is that whole idea of randomly surfing, so the randomization portion. And what that means is that we're going to establish from each node some link with a small weight to each of the other nodes in the graph. So we're going to establish a little bit from A to B, a little bit from A to C, additionally to what it already has in the cases that it's already pointing to those nodes, a little bit to D, and a little bit to E. And similarly for the other nodes, we assume that each of them are connected in a slight way, at least. And so what that random component does for us is basically it says that when I'm on a given web page, I might follow the web graph. So if I'm on B, I might go down to C. But then there's another probability, a small probability, that I might go to either A, D, E, or even C again itself. And that's the randomization component. And so with PageRank, we actually have to weight how much we're going to do that, how much we're going to randomly surf as opposed to how much we're going to follow the web graph itself. And Google actually sets in its algorithm the PageRank to be, the randomization component to be 85%, which means that 85% of the time the random surfer is going to follow the graph itself in traversing the nodes, but then 15% of the time he's going to be just entering a random URL to the browser.